So these, I'll go to one of the recent data files. So let's start with this. This is the qPCR file that I get. It's of the I think it's a EDS file, but there's this program that's from Applied Biosystems. You can download this on your computer in case you need to mess with them. So I just open this on my own computer. I see the curves and see if everything is looking all right, just like a preliminary QC. And then I export an Excel file from this. And then I go to the R code and then it eats the Excel file and then it gives us the data. So these are the raw data curves from this week. The thing I do is I just check the NTCs. So I see that a few of them have amplifications. Yeah, there's this one well where there's an amplification where I don't add any template. It's called non-template control, NTC. So given that not all of them have it, I will think that this is not a systematic issue, so we'll let it go for now. And these are the standards. So I'll go to export here and I will export this with the same name as the file that I started with. Without the date. Yeah, the one thing I forgot before you export is you want to check the threshold that it's using for. So it has this curve and it intersects this curve with a threshold line, and then it maps that point of intersection to the x-axis and it gives us this value that's called the CQ, the cycle of quantification. So just for like because we are using the standards that have been done on a different plate previously, we want to make sure that this threshold here is the same as the threshold used for the standards. So this program automatically makes a threshold looking at this curve, but I just wanted to make it manually consistent. So I choose 0.04 and I make sure to go to all the targets and check that it's the same. So that is consistent. So we have this file here and it gives you the CT values. You'll notice that the sample names are all identical except for the NTCs because it takes too long to enter the sample names in this file. So what I have here is we have a spreadsheet called calculations lab notebook. So here I have all the plates that I've done so far. I have the name of this thing, which is the title name of the file here, like the same name. It has a wastewater and some number in order. And the droplet digital ones, I start with dd.wastewater123 like that. So this file is wastewater 20, right? So I want the program to run through this 9612 format here and take in these samples and then output the data. So I wanted to correspond the CT values to these names here. So instead of giving it the row column names to crawl this data all the time, I set up another sheet here where, so if I take the name of the title, it is in C335. So if I go here and enter C335, it will import the data. So I have set this sheet up so it imports the exact data from that particular experiment. So this thing is identical to the thing on this sheet. So I set up the program to crawl this area always. So if you, before you run the code, you want to make sure you're reading the same plate that you're running. Otherwise, it will load the previous plate names and it will mess up the pipeline.
Can your code set this?
Yeah.
Do you manually? Can your code do it?
Yeah. If you want to do it through the code, then you just have to do a lot of extra steps. So you want to crawl all of these things and then see which name here matches your file name. And that's a lot of extra work.
Okay.
So I just thought it's easier to do like a one-time thing. So you go to this, this is R Studio. It's a GUI that runs the R programming language. So what I do is I have this code is being saved onto a version control system called GitHub. So GitHub is a website and you set up an account on it and you have different repositories for different codes that do different things. So I have one that does the qPCR analysis. I have been using it previously as well for even before we started the COVID work. And then I have other repositories that read other data sets. So one is for doing the growth curves of bacteria. There's another one that reads general plate reader data. Like there's a few on the side here. But all of these codes are open access. So I think anyone in the internet can watch my code and download it and use them for their own work. So the way I set it up is because the broad file is the same for all the analysis, but just the file name changes, right? If I want to analyze this week's data or last week's data, the only thing different is the file name. So, and there are also some minor changes, right? There are extra samples for a particular week and you have to rename the samples. Like there's a few things that we have been experimenting on. And if I want to manually rename stuff, I just make different branches for different weeks, different files of qPCR I'm reading. So this is a program called source tree. So this interacts with the GitHub and it shows me how, so my code has some main thing and then I branch from it. And then each branch is a different file. So these WW19 here, it corresponds to this guy. Each Excel file has a different branch basically. So let's go to the master file here. So typically this is what I do. I go to, where's this? Just go to master. You double click on it and it goes to this branch. And if there is any changes you make for a particular file, those things stay in that only that branch. So I'll go here and I'll make a new branch and I'll name it the same as the Excel file or just the code, the WW and the number. So I create a branch for that. And R automatically knows that you have changed the branch to wastewater 20. If you go here, this automatically appears the Git on the side, and this is showing wastewater 20 as the branch. So you go here and then you change the names of these things. So this is the name that appears on the document. Yeah, I just changed the date, consistency. So this is the actual pipeline for plotting. There's 4 different files. The first file is where it takes the data, the qPCR data, and it takes this manual. So it takes this thing that you have to set manually. You have to set the column here, and then it crawls and takes this data. And then it merges both of them and outputs it into a third sheet. I'll show you how it works. So here I go and I change this name. So I just go back and forth to this thing and copy paste the names all the time. So I copy that, I paste it in the file name thing. Everything else remains more or less the same. So here I have the template volume that I load per reaction. And sometimes if you change that, then it's basically going to divide all the data by that number. So you get a per microliter volume. And I have a few comments here, like if you want to figure out the code by yourself, you can read these and they'll be helpful. So there's a bunch of things that you can change here, but none of them are very relevant here. So these numbers that you see here, this is what it is using to back calculate the copy number from the CT value. I'll just give a brief overview of how that works. So I'll show a particular standard curve that we have done previously.
So just a quick comment on that, Prashant. If we eventually move towards doing one standard curve per plate, could we basically have this also, I guess we would just change the code so it reads in the standards and makes the curve.
Yeah, we can set it to do it automatically, but right now I've been doing it manually.
Right,
yeah,
okay.
So I have, so I forget that this plate has its own standards. We only started doing this recently. So we've done it only for the N1 and 2. So these are the standard values. The way you know it's a standard is because this is the starting concentration. You dilute it tenfold. Let's just see one target for now. So this is the standard. You dilute it tenfold. You're moving to a later CT. You keep diluting it, and you're supposed to see a pretty uniform looking curve pattern like that. And the starting thing is what we purchased from GeneWiz. It's a DNA of a known standard amount of DNA in it. So these values will create a graph like this. So on the x-axis is the log of the known copy number that we start with. Y-axis is this CT value that you get from the intersections here. So you take a curve like this, you run a linear regression on it, and you'll get an equation like y is equal to mx plus c. And it also gives you like the least square fitting, and you're supposed to have greater than 0.99 for a good standard curve. So it takes these values, the intercept, and it also calculates these parameters. They're called efficiency. So it tells you indirectly how much your DNA is being multiplied by in each cycle of PCR. The ideal thing is it's supposed to go twofold in each cycle, but not all PCRs work the same way because there might be some problems with the fluorescence reading, or there might be some inhibitors that your polymerase not always binds to the DNA in all the cycles properly. So this is generally either less than 2 or greater than 2. So you can see all of these are slightly greater than 2. So it does the deviation from 2, it is calculating it as the percentage efficiency. So 100% means exactly 2. And the tolerance range they say is 90 to 110. These are more or less in that range, not all of them, but so these two are the ones that we are taking into consideration, the N1 and the N2 multiplex. The first time I did, we also did a few individually N1 and N2 just to verify. But right now, the only things we are taking into account is this and the multiplex. This is where both N1 and N2 primers are in the same reaction pool. So you observe here, it has both a blue curve and a red curve. One is for N1, one is for N2 in the same well. Yeah, Zach, you were saying something?
Yeah, how can you have an efficiency over 2?
Yeah, so there's a lot of things. I don't know the actual physical meaning behind it, but it just means that your amplification is happening more than you expect, or there's like also some non-specific products might be coming along and they add to your signal. It's not your actual product being doubled. But I've seen this greater than 100% a lot of times. So I don't know if it is anything to worry about.
Okay. Do you see it in, maybe this isn't relevant to what we're talking about right now, but do you see that in the same samples? Like, is it always the standards that are over the efficiency?
Yeah, so if you calculate efficiency only with the known standards.
Right, okay.
Right? For unknown samples, there's other ways that you do. I've been trying to get it to work, but I haven't started on that yet. So another way you can do is if you analyze this curve, this is actually processed data, but the raw data looks like this. So this is the fluorescence that the machine is measuring, and it increases at some point, and at which point this increases. So it does background subtraction on this raw data, and it gives you this weird thing. And they use proprietary algorithms, so we don't know the maths behind this final curve.
Okay.
So if you go and take the raw data, you can fit a sigmoidal sigmoidal equation to this, and if you extrapolate this curve right till the x-axis is 0, you'll get an initial fluorescence value. And when you fit this data, you'll get this linear region, because this is a log. This is not a log plot. This is a log plot, so this is the linear region. So this is same as the exponential growth region here in this tiny area. So if you fit your curve to that, it will also give you another approximation of this efficiency that we are calculating, like this thing.
Okay, so
you can do that for individual samples. So for unknown, so I assume the wastewater will have different efficiency than the standard, but currently we've been assuming they are the same.
okay, so that efficiency is based on the slope of the fluorescence.
Yeah, the slope of this exponential region in the fluorescence.
Okay. And then my other question is, since we're starting to do standards for each plate, would you start changing the threshold based on the standards for each plate, or would you just want to keep it at 0.04?
I think it's fine to have the threshold anywhere in this linear region.
Okay.
So the machine automatically makes a threshold. It usually does it around this 0.1 mark. But if I reduce it slightly to 0.04, I don't think it should make much of a difference. So whether it's here or slightly increased, because you have both the standards and the real samples in the same plate, it should be more or less similar.
Okay.
Yeah, so I think I'll stick to 0.04 for now.
Okay.
So this thing has its own standards. So I have another script here that's called standard curve. Okay, so let us see this. I go here and change the file name. I haven't tested if this thing works. Generally, it might throw some errors. So let's see, this is like real-time testing.
Our standards are linear DNA?
Yeah, these standards that I'm doing right now, these are linear DNA.
Okay.
Once I have done initially was before these samples arrived. So we have this circular plasmid with the N gene in it that IDT was selling. So the initial standards that we have, these are called the N IDT standard qPCR.
Yeah. And then another question I have, in the methods meeting last Friday, there was a little bit of discussion about using RNA standards instead of DNA standards.
Yeah.
Do you think that they thought that was a better way to go, is to use RNA? I guess we're switching to ddPCR, so maybe it doesn't matter.
Yeah, so it doesn't really matter. Yeah, but
yeah, I agree. I think we're switching over. It doesn't matter. I think it's true if we were really trying to get apps. Yeah.
Yeah, so I think to be really precise, you would start with RNA standards. So in that case, you would take this DNA thing, and what I've seen other people do is they buy this in vitro translation kit. So it translates the DNA into RNA by adding that polymerase, the RNA polymerase.
Oh, okay.
DNA, I keep forgetting. Yeah, it's the polymerase that makes RNA from DNA. I think it's called RNA polymerase. So it just has that in a kit. So you have to add in your DNA thing, and then you have to kill the DNA by adding a DNA killing enzyme, DNase, and then you have to purify it. So that's another hassle that we have to go through, and we have to, I don't know how long this RNA is stable for. So that's another thing. So there's added things that you have to do if you're starting with RNA. And to buy RNA is a lot more expensive. I think somebody sells this N1 and N2 standards with the for the RNA. But I hear that they're really expensive. So I go to this file, the standard curve, and I change the file name to the same as the Excel file. And if you save, there's also a thing called source on save. If you keep that checked, it runs the file at the same time. So the command is called source. It has the thing on it. And if you guys are trying to run this on your computer, let's say if you clone it from GitHub, there's a directory called qPCR. And the way it is set up is this file starts in this directory, and there are subdirectories to this that are called the Excel files. So it goes into that and looks for the Excel file that you type the name of it. And then it goes into another thing called the qPCR analysis, and it saves the graphs and things like that here. So if you have it set up the same way, it should work for you as well. If you download it to your computer, and then we've been putting these raw data files in Google Drive. So you would download that into another thing here and then save the Excel files into this folder with the same name. It should work for you. So I have the directory linked is relative. It starts with the folder where this R project is. So the advantage with having an R project is it knows that it is starting from this directory. It's starting from this directory, so it has this R project has all the R files in it. So these are the individual files that I've been running. So that's the advantage, that it starts with this directory, and then everything that you link, all the subfolders are relative to that. So you say just say Excel files, and then you take that file name. I had it set up so it just adds the .xls, so it makes it easier. You just have to enter this thing here. So
okay, so just so I'm understanding, there's like a big folder with our project basically that that the program basically starts in, and is like that's how it finds the relative folders is based on where they are relative to that. Okay.
Yeah, that's how it is set up. So here, this guy is also reading the same location in the plate for the file, the tube names of the things that we ran. So because it's a Google Docs, you need to connect you need to authorize R to use your Google Docs account. So I had typed in my user login password once. So it's just asking which account do you want to use.
Okay.
So I just selected, but for you, it might take you to the browser and ask you for your username password. Sometimes Google makes a fuss because this is a third-party program, so it might block it or make an error, but you have to go to your Google accounts and say allow access or something like that. Okay, seems like there is an error. Okay, error in least square foot. Yeah, I have to figure that out. It might take some time. But for now, once you run that standard curve, it will give you a graph that looks like this. And you'll manually look at this graph, take the, what's this called? The y-intercept and the slope, and you'll put it here. So these are for all the ones that I have done so far. These are the latest standard curve parameters that I'm using. So this is the slope, and this is the intercept for the N1 multiplex. So this is the blue line here, minus 3.08 and 38.
Are these values reported in your like big data dump? If you have like a big data dump at the end of this, like the...
No, these values are not going to the data dump, but that's a good point. I think I can write this below each file, all of the information that goes into it.
Okay.
So, yeah, that's quite doable, I think, but it will take some time to set it up. So it takes in these values, and the thing that the code is doing, it opens up this particular sheet in this file. I guess if you want to look in. So I set it up so that there are like functions that the main file calls. Okay. So for now, we'll just use the old standard curve, even though this standard has its own standard. We'll figure that out later. So this is the file that's taking these input values that you give it, and then it's calling some this is the program called read qPCR. It's a function. I wrote that function in a different file, just like keeping them separate for easy readability. So here you'll find the read qPCR is the first function here. It's just a simple thing. It's taking this file, it's saying load the file, get all the sheets, and then it's looking for the name of the sheet. And then it's saying, okay, the sheet that has results on it, you take that guy, take the CT values and make them numeric. It's just, it takes a while to learn. You can Google up these things and learn these functions. It's quite straightforward. So if there is any text in this, it reads this whole column as a text column. So if you do any mathematical transformations on it, so using this equation to mess with those values, it gives an error. So you just convert this to a numeric, and then these guys go to no value or something like that. It's called NA, capital NA. That's all it's doing. So it takes a file there, and it's stripping all of those columns, and then it takes the names, and let's run it. And I set it up to write to one file here. That's called, that's called the qPCR data dump. So here you'll find a lot of file names. Each of them correspond to the Excel files, right? So 20 is the most recent one that we did. So all it has done, it's taken this, all of this data was in the, so the first 3 columns and this guy, these were already in the qPCR data file, but it has taken the sample name that we have given it from this sheet. So it has taken the names from here. So there's a few names with 622, and I set it up so that there's a dash in the beginning. The left side of that is the target. On the right side is the sample name. The set of the samples, they have a name, or the box that you're putting them in. And the one on the right side of the underscore is the name on the tube that you see. So it just separates them into multiple columns. So there's one is called assay variable, like the ABCDs come here. If they're biological replicates, so I have it named as O.1, O.2, for example. So it just separates the thing on the right side of the dot and makes them another column here. So I can do this for multiple files. Let's say if I have one sample set that I'm analyzing, I have one qPCR file for N1, N2, another one for the B covine. I just go individually, change the names here, and I run them. And then I have another file that crawls over this sheet, the data dump. So if I have multiple sheets that I wanted to crawl, it can crawl them and then combine their data and make a plot together. So here there's like this function, read these sheets. So here I just change it to the name of the sheet, and the name of the sheet is the same as the Excel file. So I'll just copy it from here. Yeah, so you can verify wastewater 2622 and 1-N2. It's the same as the file here. And it's reading this, and then it will output another sheet which has extra things, and that will be named as what we say here. So I'll change it to 622 rice. All right, so another thing it does is these names that we have are, so these names that are on this tube are a shortened version of the name of the wastewater treatment plant. So we have another sheet where the health department sends us a spreadsheet every week. I just copy paste it into a Google sheet. So this is called BioBot sample IDs. So this names, each week's thing is in a different sheet here. So we are interested in week 11. So this, I just rename these columns to make them readable, but you can code it so that, but it changes each week. So that's the thing. If you want to code it automatically, it doesn't work. It usually breaks. So I'm reading column H, I, and J from this sheet. So I want to tell R to read that particular sheet in this Google Sheet. So this is where I update this, the 11, and then if there's any extra things that you want to either exclude from your plot or something, you can do that here. So for now, we'll leave that whatever it is. And this is where I've been using like manually renaming the ABCDE to some of the experiments that we've been doing with wastewater, spiked in field and lab and things like that. It's hard to make them to crawl a sheet and take these things, so I just enter it manually. So currently we don't have these things, so I'll just comment that out and make that variable to an empty string. So down the line, when the code calls for this, it just takes an empty string, and so it doesn't change the data.
Okay. You might want to, I think you misspelled translate.
Oh yeah. Yeah. If you click on it, it shows other places where the same variable occurs. So that's helpful. So I changed this stuff here. And so we have the vaccine. So this guy also calculates the recoveries, if the recoveries exist. For this plate, we only have N1 and 2 data in this plate. So the target, we don't have any B-covine in them. So it cannot do recoveries anyway. So we can ignore those things. But if you have the vaccine running on the same file, currently there is no automatic way to set it up, but let's say there's a vaccine data here. So I go here and manually highlight these things, and then I take the average of these that is set up in the first sheet in this thing. So I just set up like a formula to go to that particular sheet and take the average. So I just take that number, copy it, paste it into the Google Sheet there. And then Zach, have you changed the spike volume for this week?
No. No.
So the S13 and S14, so they are also 50 microliter. So I would just take, if I'm running those B-covine samples, I would copy this number and paste it here. You can do it right now actually.
And then your HA concentration factor, that's like you take 50. How do you come up with that 500? It's because you have 50 milliliters.
Yeah, so we are taking 50 ml and we run it through the filter, and then the filter goes into the RNA extraction, and 50 microliters of the whole thing comes out, the RNA and water, right? So it's 50 ml divided by 50 microliters. So that should be 1,000. So you want to make sure and change that. So this was set up to run previous samples where there was we were eluting in 100 microliters. So that's why that was different.
Okay, so
these are the things that change every week. If it does change, then you want to manually make sure that it's set to that.
Okay, so your concentration factors just go, they don't account for any of the...
What do you mean?
Well, in the extraction process, there's like...
Oh yeah, there's some volume that you're missing out, right? Yeah. I don't have that information, so I haven't been able to put it into the code.
Okay, I have that information and I can help add it.
Sure, yeah, we just have to rerun the old data probably.
Yeah. And
so I think there'll be a factor of what, like 10% or something might increase compared to this factor.
Yeah, something like that. It'll be different for the QI than it will be for like this week. I mean, in the previous weeks.
Just a minute. So you just change all of these parameters, and then I don't know if this thing will make it throw up an error. Let's see. So we'll just click run. Oh, this does nothing to it because it's an R markdown file. So you want to press knit on it. So it's going to take each. So this code is divided into sections. Each section will have like it can have text on it. You can have the title and some commentary, and then the plot. So it runs each of these one by one when you press knit, and it makes the output into a HTML file that looks like this. While the code is running, it keeps giving things here. I can show you one of the previous data files. So I've just taken the data, and because there's multiple things we want to plot, I just do multiple plots on it, and once you run the file, all of them come at the same time. So I'd meant to add scatter plots in this, but I haven't done that yet. So this first plot is just individual biological replicates. The second one is taking A1, A2, A3, merging them into A. And it also converts the name. So A, B, C, D, these are the names that are written on the tubes. But then it takes this guy, and then it converts those, let's say 622A. Dot A. So it takes that guy and it converts this into GR or Greenridge. So I think it's hard to have like a long text format in the x-axis of the labeling. I don't like labeling things like tilted or vertical. So I just have the 2-letter names here. So that's one of the plots. The other one is just, so this is all plotting everything, N1, N2, and B covine. And this one has just the N1. And so there are like 2 units here. One is so it converts the CT number into copy numbers and divides by the template volume that you have seen in this sheet here. Right, so it is giving us per microliter of the RNA that we are loading in, but then there's a concentration factor from the RNA to the wastewater, that is this thing. So it takes in both of them into account and changes the units from per microliter to per liter because it's convenient for wastewater. So it outputs this, and then this is the expected amount that you're supposed to find by taking into account this the vaccine concentration that you spiked in. This is copies per microliter, and you multiply it by number of microliters you spiked in. So that is the raw value per liter of wastewater. And then there's also the volume spiked in for each thing is different, right? David, you would have noticed that when you went to sampling this week. So that thing is in a different sheet. Okay. This doesn't let me. That sheet is called the sample registry, which the concentration people have been updating every week. So here there's a row for the total wastewater volume measured. So it takes in that and it divides by that to get the. To get the final per liter of wastewater value. I think I close this file. Yeah, so to go from per microliter to per liter, it's taking those values, and so it multiplies this thing into that, divides by the wastewater volume that's taken from that sheet.
Okay.
Yeah, so it's just calling multiple sheets. So just keep track. Like recently, I think one of you changed the name of the column here, so it threw up an error, and I just went back and recorded it. It used to be total wastewater volume, but I think you added a new column for calculated and then measured. that's fine. So we just go here and change the name that it's calling. Okay, it throws up an error. Yeah, so it says line 79, there's an error. So you go hunt for it. Let's see in 2 minutes if you can find the error. Otherwise, that's the overview is almost done.
Do you remember for the 601s, which vaccine you were comparing for recovery?
For the 601s, I think I used the S13 possibly.
Okay.
Yeah, I go by whatever is written here.
Okay. They shouldn't have spiked the 601s. But maybe they did. The 601 should have been spiked.
So, the 601s were the old spikes, right?
Yeah.
Yeah, so I think I took whatever was the oldest spike data we have.
There should be so that spike was from before when I started naming it, but if you look at the dates on the stock registry or whatever, I could probably pick out the one that.
Yeah, so 601 is here and there's nothing written here, but I assume this is the first sample that we spiked in.
Well, if you look at the stock thing, can you look at the stock? If you've done
okay, this guy?
Yeah. Yeah, it should have been the 6.2 one. I don't know if you have any sort of way to figure out which one that was, but
yeah, it would be hard to do that because it was not named. Like the vaccine RNA extract that I ran doesn't have the same name, so there'll be a lot more like detective work to do that.
Okay.
So I think I caught the error here. It's going to that sheet for the biobot names. It's looking at column HIJ. And the troubling part is they change their format between each week. So for older weeks, it stops at column I. So for this week, it is HIJ, right? I think I have to make these names the same as previous week. So now it should hopefully work. While it's running, I made a change. Another error somewhere else. Yeah, we'll figure that out later. But the main idea is it takes those things from the raw file and then it makes two more Excel Google Sheets. One is called the qPCR to present plus recovery. So it's taking all the data that we have. This file has not run, but we'll look at one from the previous file. So it took in the data, it added these names that it took from the biobot file, and it replaced it with the internal names that we had from the tubes. It removes them, and this data goes to the health department directly. So they don't need to have those extra columns. So I just removed them, and it has the recovery. If you ran any bcovine, these values have recoveries on them. For N1, N2, there's no recovery written on them.
Okay.
And there's another file that's called Stadler COV2 qPCR to present. So this is the same as the previous sheet, except it has only N1, N2 data in them. And this is what we have been giving to the health department. So you don't need to go here and remove these columns. The program just removes them for you and makes a different sheet. So it's just a little confusing because there's many places. The data is distributed in many places. but it's much easier to do it with a program. So this is the same data as here with just N1, N2 values, and it doesn't have that extra column with the recoveries and the spiking.
Okay.
Yeah, so that's all there is to the code.
Okay.
If you see any errors, it tells you which line there is, and you just have to probably go and Google what that function is doing. So the only thing is R has this neat feature. So I load a bunch of packages here when I'm running my thing. So these are called libraries. If there's any extra functions that are not there normally in this R program, you load them, you install them first, so it downloads to your computer, and then you load them with each run. So you call the library function, and it has a bunch of packages that I'm using. So the Google Sheets, the reason I'm able to get them easily is because there's a package that's called Google Sheets for. And to read Excel, there's that, and this thing, and all the tabular functions that I'm using, they're made easy by this thing called tidyverse. I guess if you start using it, then you'll learn all of these things one by one.
Mm-hmm.
But if you already start with the code, it's very easy to pick up. Like if you see an error happening here, you go to that line and you Google the functions that I'm using to see where the problem is. So the only main thing is this code is written using this margritter. So if you're writing a function of a function, let's say you have a is equal to 1, 2, 4, right? If you want to do a into 10, you can write it as a function like this, a, and you pipe, this is called the pipe operator. You multiply into an arbitrary function where the function takes whatever you're giving it, multiplies by 10. Okay, there's a way to write it properly. That's not working out. So let's say I want to do the mean of that. I could write a function like this, mean a, or I could write it the way I wrote it previously. If you want to do mean, and then you want to do something with it, divide by 4 or something like that. There's a way to write these things. Yeah, so you can chain multiple functions like that using this operator. So that's what I've done here. I go to that function, filter out things that I don't need, and then there's another function that's selecting only a few columns, and then it's changing the column names of a few things. So this translate that we made an empty string initially. So it changes the names of things manually if you want to change anything. And then it's doing a lot more operations basically. So it makes it easy to read. It just takes a little more practice because there's a lot of functions combined into one line.
Mm-hmm.
So if there's an error in 125, I think it probably has to do with that guy, the error. We can try removing that and see if the error still persists.
Okay. I have
Re-enable the old stuff.
a couple thoughts, questions.
Yeah.
Would it be possible, like when you generate the raw data dump, to also include like all the like metadata type stuff that was included in the calculations, like concentration factor, spike virus concentration,
Yeah,
virus volume, standard or information on the standards, I guess, for qPCR, like just all that stuff, just so we could like look at it.
yeah, that's a good idea. I will
Just
plan
like
and
at
bring
the
them.
end of the file or end of the spreadsheet or whatever. And
Yeah,
then
that's a really good idea.
would you, I don't know if this would be a lot of work because you just basically showed it to us, but it's kind of hard for us. Would you be able to like maybe just do a brief like step-by-step outline of what you do, like of what you need to change each time? you like process the data. So if like one of us wanted to, like, so we just watched you do it here. Guess we would have to come back and kind of watch the video, I think, to like do it. But would you be able to like just do like step one, change file name here to correspond to this file name, or is that too? Sorry, I don't know.
Like you want me to add text onto the video or something to guide people?
Oh, I guess I could just, maybe I can come back after. Well, I was just hoping if like we could just get like a Google, like just a really brief Google protocol to
Sure, yeah, that's doable.
document or whatever, or Google Doc or whatever, just
Yeah.
to like, so we know like what we have to do exactly each time we would want to run this. So I know
Yeah.
you just explained it to us in this video, but it's definitely good to see it like in person. But it also I think would help us if we were like, yeah,
that makes sense.
just if it was written out.
I mean, moving forward, aren't we using ddPCR? So like stuff about standard curves and stuff would.
Yeah, that thing won't be there, but everything else would remain the same, right? So instead of taking the Excel file, I would just replace this whole thing. So these two files would be not necessary anymore.
Okay,
Because you're getting copy number directly. So you just take this and you make it start with. So instead of crawling this sheet, what I would do is to crawl the ddPCR sheet, and then it should work the same way.
Maybe, but as far as ddPCR, maybe we want to have, this might be a separate conversation, but maybe every time we run a plate, we want to have just like some standards of known quantity just for a quality control measure. I don't know.
Yeah. We'll probably end up doing that.
But okay. Yeah, can I work with you to try to, for the extraction volumes, maybe get those involved in the concentration factor?
Yeah.
Because I think it's more than 10% loss. And like,
yeah, the extraction values that we have are really low, mostly less than 1%.
So, I mean, I just think it would help with like comparability across weeks and other things.
Yeah, definitely. If it is standardized, then it should be straightforward to include that. Like I can just do 1000 multiplied by that factor.
I guess, I mean, like now we're moving to having a standard volume for our extraction stuff, but like the past weeks, it's been different. So
that's true.
If we want to, try to, if we're trying to compare between weeks, then we need to like incorporate that.
Yeah. There's also one data set that I was going to bring up sometime. Let me see if it's doable. No, seems like not. So the extraction that we get even from water is quite low. It is again sub 1%.
Yeah.
So even if you add those factors in, Zach, like what you were saying,
yeah,
I don't know if it will make much of a difference to the conclusion. But it is definitely a good idea to go back and follow up on that. I can show you, for example, this data is the recent ones. Okay, these are wastewater samples. I haven't plotted these ones. They are removed from the plot. Yeah, but for example, the water, wastewater thing here, and the solids removed before removing and after removing. You still see very low efficiency from them. So Zach, the correction that you told me, for the vaccine concentration. After incorporating that, it's 25% from water.
Yeah.
25 or less.
I mean, as long as these recoveries are consistent, though, between weeks, then I think it still matters.
Yeah,
right?
but I guess the biggest improvement in method, if we keep running this water stuff, whenever we are trying to improve the method, just like the DI water spiked in different time points, I think that will be very helpful. Because if this is improved to 50% or more, then the wastewater will improve as well.
Yeah.
Yeah, I can write up those things that you mentioned.
Sorry to ask you to do that. Thank you.
Yeah, sure.
Do you think like moving forward it'd be easier to like create some sort of separate configuration file that one would change from week to week, and then in the code have those variables that change week to week read that configuration file for that week? So
yeah,
you
I
don't
think
have
that's doable.
every week and make a new branch or anything. You would just you'd only make a new branch if you were really editing like core functionality of the code. Like you'd only edit this configuration file that you would just kind of save on the side or something.
I guess it makes sense if you only run the actual samples every week, right? But we have a few extra things that we do, and those things require, like, if you combine two data sets on one plate, then your code will fail because you're only expecting it to run one streamlined data set.
Right.
Yeah.
I guess another question would be then, like, it's like the question of what we want the script to handle. It's like right now it handles everything, but should we have like a separate thing that's like incredibly streamlined just for the task, which is just the samples that are being sent to the health department?
Yeah.
And then we have another pipeline for all the experiments that we're doing on the side. So like it makes the process easier because all you're doing is changing a few variable names for a config. I guess the problem then is that it becomes incredibly difficult to put samples on the same PCR plate, like the experimental samples versus the weekly data samples.
Yeah. So I can make like a branch, maybe simplify this code to streamline it a little, and then we can work together on making this config file and reading stuff from that.
Yeah.
Currently, I just set up all the user inputs to be at the beginning, and I have like comments on what I want the users to input. So the only thing that would be different is those would be in an Excel file.
Okay.
I also prefer Google Docs over Excel files because you don't need to synchronize it with people or email it to them or something. Also, I haven't been able to figure out a good function to write to Excel sheets. So it's much easier to write to Google Docs as of now.